Hello, ladies and gentlemen, and welcome back. We're on question 22 of our Fermat paper, which reads as follows. In the diagram, two straight lines are to be drawn through the origin, so that the lines divide figure OPQRST, okay, all the way through there, into three pieces of equal area. The sums of the slopes of the lines will be. Okay. So we've got sort of a nice rectangular-ish figures. We sort of have a big squarey chunk and then a tinier, more rectangularly chunk. And I'm supposed to draw two lines that divide this into three parts. So the question is, what are the lines going to look like? Because that's where we go hunting for things. So, you know, is one of the lines here, is this a third of the area? Or do I have to, go all the way over here to get a third of the area? And then how do we split? Do we split over here to get a third of the area? Or, do we need that for a third of the area? So there's going to be a little bit of experimentation. If I'm trying to split the area, it'd probably be a good idea to know what the area of this thing is, period. So, so it starts at 0, 6. So a height of 6. And then what was it? It went over 6, 6. So this is part of a square. And then I think I said it was 12. I want to say 2. Yeah, 12, 2. 12, 0. And this one, I guess, would have to be 6, 2. Yeah, there we go. Okay, so the first thing I'm going to do is just figure out the areas here. I'm going to drop and get the square. Yes, I could drop and get this one, but I'm going to focus on the square because it seems like it's going to have a much bigger area. So this is 6 by 6. That's an area of 36. This is 6 by 2, so an area of 12. So total area is 48. If I divide that into thirds, each area is going to have 16. Okay. Now, if I were just to, let's switch some colors here a bit. If I were just going to cut across up to this corner, I'd have this split into 18 and 18, because we're splitting the square in half. But 18 is a bit too much. Okay, so that tells me that I'm going to need to draw my purple line, I guess, a little further over. But that does tell me where I need to place my purple line. So I need to get an area of 16. So, that's a good attacking point. Now, as for the second line, the second line is, well, let's use the same sort of thing. We'll go for a corner. We'll use the orange. So imagine I were right at this corner. Is this too much or is this too little? So we'd have 12, and then we'd have 2 by 6, a nice little right angle here. So that'll be 12 and 6. So that'll also be 18, and that also is too much. So that tells me my other line is going to have to pass through here. And so now the question is, well, okay, it passes through there. What must those points be? So up here for the purple one, we've got a nice little right angle triangle, and I can see I have a base of 6, and I need to get, so let's say we go along x distance here. I know that 6 times x, 1/2 6 times x, which is 3x, needs to be 16. So the x coordinate of this point needs to be 16 thirds. And of course the height's going to be the same old 6. So from there I can figure out the slope. Okay, the slope will just be rise over run. I don't know why I'm erasing that. That was actually a good calculation. Okay, what can we say here? I suppose if I call the other distance we go over y, then I'll have, let's use more color again, this blue right-angled triangle here, which has a height of 2 and a base of y, and then over here we've got 12 minus y times 2. And that has to add up to 16. So 16 is 1/2 2 times y plus 2 times 12 minus y. So this is going to be y plus 24 minus 2y, or 24 minus y, so y is going to have to be 8. So we get 8, 2 here. So now we just need, don't need to change color, I just need the slopes. And slopes are just going to be rise over run. So rise to get from the origin, because we know these both pass to the origin, so we do have a point on these lines. Rise, and then run here. That's going to be 6 over 16 thirds. Invert and multiply, I'm going to get 18 over 16. And then for our other one, we'll have, we rise up by 2, we'll run by 8, so that'll be 2 over 8, or 1/4. And I suppose this could be simplified to 9/8. I guess I'll leave it as 2/8 then. Makes it easy to add them up. And we did want the sum, right? Not the difference or anything like that. Sum of the slopes of the line will be 9/8 plus 2/8, and that's going to be 11/8. And that is E. And that finishes off question number 2 rather nicely. Very interesting little question. Very interesting. But, you know, fell before the might of our geometry and our sort of coordinate system. But good question nonetheless. Up next, of course, question number 23, and I will see you for that in the next video.